right, welcome back to part 2 of mixed operation two-step word problems. Having a little technical video issue with the storage on my iPad today. So I'm going to send this out in 2 parts. We left off, and I'm not going to rewrite that just to save myself a little bit of time. I'm not going to rewrite all the problem solving steps and important information, but I know from the last video we left off, we were going to be multiplying 14 times 8 because we have 14 boxes, 8 markers in a box. This is going to give us the total number of markers the boys have all together. So we left off doing the area model for 14 times 8. It is a 2-digit by 1-digit number, so our area model would be 1 row, 2 columns. I decompose the 14 into 10 plus 4, and then I multiply the area to find the area of each of these boxes. So 10 times 8 is 80. I could write the equation, but I don't need to if I can, if my work makes sense. And I write the product. 8 times 4 is 32. Now I'm going to add those 2 partial products up. 2 and 11. All right. So I would go back to my answer statement, which I don't have written here anymore, but it would be Jonah and Eric have 112 markers all together. And I think about whether that answer makes sense. Is it reasonable? And one of the ways that we can think about is through estimation. So I could say to myself, well, what if I rounded 8 to the nearest 10 to 10, and each box had 10 markers? Well, 14 times 10 is 140. My answer is pretty close, a little less than 140. That makes sense because 8 is a little less than 10. So I know that my answer is reasonable, and I can feel pretty confident that that is the correct answer. So then I can go on and move on to the next problem, having thought that one through. Now we're going to try one more problem. Just checking, make sure my video is still working. I keep thinking it's going to shut down on me. So we're going to clear our boards. And we've been talking about perseverance, because these problems can take a while sometimes to think through them. And if our answer is not reasonable at the end, we might need to go and make some changes to that. So I'm going to read this for you. I know it's a tiny print. The store ordered small posters and large posters to promote their opening. 12 times as many small posters were ordered as large posters. If there were 48 large posters, how many more small posters were ordered than large posters? Oh boy, I'm a little bit confused. Small posters, large posters, what is going on? I need to go through and kind of talk it through and pull out that important information, picture what's going on. I know there's a store and it's opening up, and they've got smaller posters and some bigger posters. And they have, sounds like different numbers of each. And I've got to figure something out with that. Let's figure that out. So what are my clues? There are 12 times as many small posters as large posters. So 12 times as many small. I'm just going to say small. I know I'm talking about posters. These are just my notes. 12 times as many small posters than large. Okay, next it says there were 48 large. 48 large. So that means there was exactly 48 large. I know the number of large posters I have. I might even write it up in my little picture. I know I have 48 large. How many more small posters were ordered than large posters? So that's my question. So I'm going to write my answer statement now. There were, go ahead and take that question and turn it back into a sentence. There were blank more small ordered than large. Okay, so I need to find out how many more small. I'm also thinking, that's kind of a clue to me. Whenever I hear how many more, I should be thinking that I need to find a difference. I'm going to have to be subtracting numbers to find what's the difference between them. So I'm going to keep that in my mind, that I'm probably going to have to use subtraction here. So I know there are 48. I need to figure out how many small there were. Well, I have a clue about small. It says 12 times as many small as the large. Oh, times is a clue for multiplication. So I actually have 48 large and 12 times that. So my first step is going to be 48 times 12. That's going to give me how many small posters were ordered. Okay? So when I have a 2-digit by 2-digit, I call that the double-decker area model with 2 columns and 2 rows, and decompose both of my factors, 40 plus 8, 10 plus 2. Just to kind of save a little time in the video, I'm not going to write all my equations, but I'm going to kind of talk through. 10 times 40 is 400. I have 2 zeros. 1 times 4 is 4 with 2 zeros is 400. 10 times 8 is 80. 2 times 40 is also 80. 2 times 8 is 16. So I'm going to go ahead and add these up. I have 400. 80 plus 80 is 160. I'm going to do that in my head. Plus 16. Now, if your child needs to write all of that out, like 400 plus 80 plus 80 plus 16, that's fine. 6, 7, 5. All right, so this just told me that I have 576 small posters. Okay, but my question isn't how many small posters do you have, it's how many more. And that's when I was thinking about subtraction. So to find out the difference, I'm going to subtract the smaller number from the larger number. 568 minus 48. But I need to do some ungrouping. This becomes a 6, this becomes a 16. 16 minus 8 is 8. 6 minus 4 is 2. 5 minus 0 is 5. So it looks like there were 528 more small posters ordered than large. Let me think about if that makes sense, if that's reasonable or not. So I'm thinking, I know that 48 is pretty close to 50. So if I did 50 times 12, that would have been about 600 posters. And then that's a lot compared to the large posters. So when I subtract, I imagine I'm still going to be in the 500s, all right? So even if I said this was 600 minus 50 and I did some rounding, 600 minus 50 would be 550. So my answer is still up in the 500s. It's a pretty big difference. I'm feeling like my answer is reasonable here. You know, if my final answer had come, there were 5 more posters, I'd have to really kind of think about that. That would mean there are only 53. Well, 12 times 48 can't only be 53. That doesn't make sense. So that kind of thinking about it is a hard skill that's going to develop with time. A lot of them, you know, a lot of our kiddos just want to get the problem done and call it a day and don't want to take the time to do that step. But the more we encourage them to do that and model it for them, the more they'll start to see the value in it. But these problems can be quite complicated and challenging, and they really do need to kind of think through and match the actions in the story with the operations, which is also hard. So give the homework problems a try tonight. They have 3 problems. Use your problem-solving steps and just persevere through them. You know, just try your best. Get something down on paper. There is no reason to come and say, I couldn't do it, and have nothing down. You haven't tried anything. Try something, all right? The answers are actually, I think the answers are given. I'm not going to say that for sure. On the work we did in class today, there were. But if the answer is already there, then the students can use that as a checking. They still have to show their work, but they know that they got it. All right, happy homeworking.